And it's a formula. And by the way, once you get to calculus, this is gone. Because we can then find out what this formula is just by doing something called the derivative. Take the derivative, set it equal to 0, will actually give me this x value. So you don't need the formula anymore. So it's gone. So, but because algebra is so limited, you have to use certain things in algebra, formulas that replace the calculus. And once you get into calculus, there's certain things that go by the wayside you don't need anymore because you have another tool in your toolbox that you don't have here. Or you have another tool, you'll find you'll have tools in your toolbox here that you didn't have in intermediate algebra. So every time you turn around, you're buying new tools. I don't buy new tools anymore. I used to. I don't do much of my own home repair. I still got a ton of tools in my garage, but I just don't use them. So I try to now not buy anything that looks, I'd love to have that tool. And now I don't use it, so. So you're building a toolbox, a math toolbox. It says, the vertex of a parabola whose equation is of the form ax squared plus bx plus c. Up until now, when we go back to the previous page, in order to find the vertex, in order to do anything in terms of doing a graph of this thing, what I had to do was to complete the square. Now this says is, you know what, don't need to do that. Don't need to do that. And maybe I'll do a little, either a pencast or a little video that actually proves that to you, but I won't do that now. And the formula is this. The formula for the vertex, this is what we used in intermediate algebra. The x coordinate of the vertex is minus b over 2a. And the y coordinate of the vertex says take the x value you find. So this is really f of the x coordinate of the vertex. So because if you put in x, you get out y, put in x, get out y, put in x, get out y, put in x, get out y. So I now have a formula. Minus b over 2a will give me the x coordinate of the vertex and the y coordinate of the vertex. So if I were going to graph this guy, the first thing I need is the vertex. The vertex is in the middle of the whole graph. So that if I know what the vertex is, then I can handle the graph because all I do is pull points on either side of the vertex. That gives me that shape of the bowl. But I got to know what the vertex is. So if I had something of the form negative x squared plus 4x minus 1, and this is in standard general form, and so we look at it and we'd say that A was negative 1, B is 4, C is negative 1. So that the x coordinate, and I'll put my little v down there, the x coordinate of the vertex is minus b over 2a, which is minus 4 over 2 times negative 1, which is minus 4 over 2, which is minus 4 over minus 2, which is positive 2. So the x coordinate of vertex is minus 2. The y coordinate of the vertex, I just put in 2 for x and get out y. So that says that the vertex is 2, 3. If I were to go back to the problem where I completed the square, if you look at this guy, well, let's see. Six of one, half dozen the other. If I were to look at the formation that I have here, what's the vertex? If you look at this guy, what's the vertex? Yeah, negative 1, negative 3. That's the vertex, right? And we had to complete the square to find that. So what if I were to say instead, and I gotta find a little piece of space here, I know that the x coordinate of the vertex is minus b over 2a, which is b in this case is, whoops, move him down, b is 6, so it's minus 6 over 2 times a is 3, which is negative 1. Well, that's what we got here, right? Negative 1, negative 1. And then that would mean that if I plug in negative 1, what should I get? Negative 3. So that f of negative 1 is 3 times negative 1 squared plus 6 times negative 1, which is indeed negative 3. So that says, do I have to complete the square anymore in order to find the vertex of this thing? No. Which, as always, when we complete the square, is that we use really for something else. Weirdness of all weirdness.